Okay, good morning everyone and welcome to our subject. Again, principles of steel design, and for today, we will be continuing our discussion with the analysis of compression members. So, last time, we have discussed how the value of P or yung Euler buckling load natin was derived, and also we get yung Euler's buckling stress, and then we try to explain uh, what what do we do kapag halimbawa nagbago yung assumption natin or yung mismong boundary condition natin. Let's say for example, hindi na siya naging pin-pin yung connection natin. So we intend to introduce a factor that we try to multiply dun sa length natin to call it an effective length or to consider this an effective length, and then to calculate yung slenderness ratio ng column natin. Okay? So as a recall at as recap to, no, yung effective length of column natin pertains dun sa length ng column multiplied by a factor k. Okay? So this factor k is based from the uh, boundary conditions na meron tayo or yung support condition natin na yung value niya will be based dun sa table na binigay natin, which is itong table sa ibang book sa libro ni Segi, that is table 5.1, pero I given you the table from AISC table C dash A dash 7.1. So ito yun, so we have 6 cases, case A, B, C, D, E, and F. So nagba-vary yung kanyang mga support conditions. So yung meaning ng bawat support indicated there are all explained naman dito sa ilalim. And then again, for our solution, we will be using always yung recommended design value, yung naka-highlight po. Never yung theoretical. Kasi nga, kung theoretical siya, it's just a theoretical value. Kaya nga naglagay sila ng recommended, yun ang gamitin natin. Okay? So, we will be using recommended design value in calculating for the capacity of our column. Right? And then, we also discussed some of the invariances that happens dun sa W shape natin when it is being fabricated. And one of these is yung residual stress tinatawag natin na nagre-reduce ng stiffness ng mismong column natin or nagre-reduce yung capacity, yung load carrying capacity ng column natin. Kasi nga, kapag nakast or nabuo na yung shape natin, hindi sabay-sabay nagko-cool down yung parts ng section natin. And that, kumbaga, diba, pag tumigas yung shape ng column natin, solidify siya. So, portion of our shape, specifically itong intersection ng web at flange, mas huli siyang nade-develop, and that causes decrease in the capacity of our section. And according to this diagram, ito nga yung ideal and real behavior ng column natin. Bago niya ma-attain yung yield strength na requirement natin for our design, it would take a number of multiple strain comparing with the ideal one. So, kumbaga, mas matagal siyang ma-develop. Okay? And that causes reduction in the performance of our column. Also, we also have yung geometric imperfections natin kasi nga, not every fabricated shapes natin are perfect. Some of those shapes will have some a little deformations. Meron sa kanila may konting yupi, meron medyo hindi naka-align, hindi siya perfectly plumb, o hindi siya straight na straight. And hindi natin makakontrol lagi yan, that is part of the invariances nga or yung mga unwanted phenomena na kapag ginagawa na sa site or actual production of fabrication ng shape natin, minsan hindi siya talaga 100% na-control, and that contribute to a reduction ulit doon sa loading capacity natin ng column natin. Kaya nga, sabi ni code or as mentioned by ASC and NSCP, kailangan magkameron tayo ng multiplier or reduction factor doon sa mismong stress value natin. Okay? And kaya papasok tayo dito sa code ni NSCP from Section 505, the design of compression members. So, ang goal natin is kapag nag-analyze tayo, malaman natin yung load carrying capacity o yung P value ng ating column. So, for LRFD, gamit tayo 0.9. And then for ASD, di-divide natin siya ng 1.67. So, pareha siya nung sa yielding o cross-section yielding natin for tension members. Ano? So, ayan, ito yung formula. And then as you can see, yung formula number 2 natin, yung para sa flexural backline stress natin, this is what we will be using para dun sa capacity natin. Ano? Ito yung capacity required natin. Ang kailangan natin is FCR value. And as you can see, si FCR will have two different cases depending on the performance nung o yung value ng KL over R natin. Okay? And ito nga yung meron tayong itong portion na to and itong portion na to. And that values are based from this diagram or this graph. Okay? So again, this graph pertains dun sa relation ng pagtaas ng KL over R with the stress na i-experience mismo nung or yung kayang stress na ibigay, no? Yung yung load carrying capacity ng mismong section natin. And as mentioned dun din sa previous discussion natin, kapag less than siya or itong portion na to less than, ito-consider natin siyang inelastic yung backlink natin. Okay? Inelastic, ibig sabihin, once deform siya, hindi siya 100% babalik dun sa original shape niya. So may permanent deformation na siya. And then we have elastic backlink dito. Okay? And kapag elastic siya, mapapansin niyo mas malaki yung pabinaba ng kanyang value ng stress, ano? Comparing with an elastic backlink column or na buckle na column in the inelastic region. Okay? So going back dito, sabi kapag less than or equal do sa 4.71, yung limit natin na nakaset dito sa graph, ito yung ating inelastic. And then ito yung ating elastic. So, madali lang naman gamitin yung formula na yan. You just need to be careful dito sa formula nitong sa inelastic kasi naka-raise as a fraction yung Fy over Fe and then multiplied by Fy, yung lahat ng factor na yun. And then for the other one, multiply lang natin ng 0.877. So, nire-reduce natin yung Euler's buckling load natin. Yung nagkakos ng buckled shape dun sa section natin na ito, na-derive natin to last time, na hindi na magbabago yung value niyan. Okay? Ay, yung formula, I mean. Okay? So, yan. Ito lang yung ayon sa code, ano? Kaya, again, nagkameron ng mga reduction yan to account for the invariances that happens whenever our column or our W shape are fabricated and used, ano? Dun sa, as our member para dun sa moment resisting frame natin. Okay? So, now we will be moving forward sa pag-analyze ng actually loaded columns natin. So, actually, our goal again is to find yung value ng P, ano? To get the value of P, kung malaman natin yung value ng load na kayang i-carry ng column natin. So, bakit kailangan natin malaman yung value ng P, ano? It serve as, ang purpose na is, una, para sa safety, para alam natin kung yung steel column natin can withstand yung mga expected loading natin in the future, no? Para kung halimbawa hindi yung applied loading natin is greater than dun sa load carrying capacity ng column natin, ibig sabihin hindi kaya nung section natin. So we need to increase or to change yung shape na gagamitin natin. Okay? Also, para sa compliance ng code, ano? So, hindi siya i-accept ng mga building codes and regulation if yung mismong capacity natin o yung p-value na makukuha natin is less than dun sa mga possible loadings na ma-apply do sa lifespan ng structure natin. Kaya kailangan malaman natin yung value ng P ng section natin. And to do that, we have two methods. The first method is using yung equation na we have discussed prior. Okay? Ibig sabihin itong mga equations na to. Okay? So So, using equation E3 sa AISC or yung NSCP Section 505.3. Okay? And then another method is using a table or a design aid na meron si AISC. Okay? Pero for today's discussion, we will just focus on method 1 muna tayo. Okay? So, method 1 lang muna tayo, and then on our succeeding discussion, lecture, we will be shifting to table 4-1A na method. Okay? Pero you have to note that both methods are or will yield the same answer. So, we can use any of the methods to check each other or one another if nag-a-analyze na tayo ng mga section natin. Okay? So, punta tayo sa method 1. So, for method 1, ito lang yung steps na kailangan natin i-consider. Number 1 is to determine yung largest KL over R value natin for the column. Okay? So, again, ang kailangan natin is yung KL over R na pinakamalaki kasi nga, according to our backlink graph, as the value of the KL over R increases, yung value ng stress natin decreases. And for us to have a conservative design, we need to consider yung worst case scenario. Kaya dun tayo sa largest value ng KL over R. We need to note na we are more focused on having a largest value ng KL over R and not the largest value ng R. Okay? KL over R po ang concern natin. And then after that, after natin ma-determine ng KL over R nung column natin, we compute yung FE o yung ating Euler's backlink load using yung KL over R na calculate natin. So substitute lang natin dito sa equation na to. And then we can compute yung FCR natin. So si FCR will depend on the value of our KL over R. So i-compare natin yung nakuha natin KL over R sa number 1 with the value of 4.71 square root of E over Fy. Okay? So i-compare natin dyan sa dalawang yan. And then whichever governs, yun yung gagamitin natin dito. Okay? So for English, okay, diba yung modulus of elasticity, baka nalilimutan lang, yung E natin, for English, for SI muna, for SI ang ginagamit natin is 200,000 megapascal yung constant natin. And for English, we are using 29,000 KSI. Okay? So, you have to be careful with that, Baka makalimut lang sila na dapat yung value nung natin, kapag English yung given na section, ito yung gagamitin natin, hindi yung 200. Okay? Kaya, please be careful with that. Then, once we have yung value ng FCR, multiply lang natin with the area. Makukuha na natin yung nominal capacity. And then, kung LRFD yung pinapahanap, multiply lang natin ng 0.9, or kapag ASD, divide lang natin with our safety factor na 1.67. So, after that, you will have yung capacity mo, and then we can now compare whether our section can withstand a given loading or not, or depende do sa hinahanap do sa problem natin. Okay? So, to demonstrate this steps, let's have an example. So, first example natin, so let's utilize the previous example we had sa previous discussion natin in identifying yung KL over R natin. So, don't worry if you have not yet viewed yung first lecture natin prior this. Ibabalikan natin kung paano ina-identify ngayon yung worst case o yung largest KL over R natin. Okay? So, the question is, analyze the W14 by 90 column shown using A992 steel. And then, what is the design capacity of this section? So, mapapansin ninyo, yung given na column sa atin, meron siyang mga may mga nakatukod na beam sa kanya on both directions, So, we need to interpret muna which direction is yung sa strong axis natin and dun sa weak axis natin. And like before, ito 'di ba yung ating base plate, okay? Doon sa base plate natin, again, ganito yung itsura ng sa base plate natin. Ito yung I section natin. And as you can see, ito yung ating Y direction. Ito yung ating X direction. So, ibig sabihin dito, kung ipa-plot natin, this is our X, this is our Y. Okay? So, ang strong axis natin is laging moment about dun sa axis natin na x, ano? So, ibig sabihin, moment about dun sa x natin. Okay? So, ibig sabihin, yung movement natin is, iikot ka dun sa axis na yun. So, ibig sabihin, yung moment mo, pag ganito, no? So, pag titingin ka ngayon, kung paano mo i-graph ngayon yung strong axis mo, ganito yung magiging itsura niya sa, parang yung free body diagram niya. It will be a fix at the end. And then, ano ba yung mga tumutulong dun sa mismong bending natin? Mapapansin natin, dito sa level na 'to, wala naman siyang beam dito na nakatukod para i-counteract 'tong moment na 'to. Also dito, wala din ditong nakatukod. Dito lang siya sa taas may nakatukod, ano? So it means dito meron siya ditong naka-pin sa kanya, no? So, pin yung assumption natin kasi puwedeng halimbawa dito nung wineld yung mga column natin, yung mga beam natin dun sa column, puwedeng ang nilagyan lang niya ng welding is yung mismong top, yung mismong flanges lang. Eh, hindi natin alam kung ano. Kaya ang safe assumption natin is naka-pin siya. Okay? So, ano yung length natin ngayon? Yung length natin diyan is 35 feet. Okay? So, this is 35 feet. And then this is our strong axis to, no? Ito yung strong axis natin. And then we also um, draw yung sa ano naman natin sa weak axis natin. So sa weak axis naman about y axis naman tayo. So ibig sabihin ang rotation naman natin pag ganito, okay? So ibig sabihin yung moment natin pag ganito yung sway ng column natin. So kung papansinin mo ano yung mga nakatukod ngayon. So for every level meron siya nakatukod dito. Okay, may nakatukod dito and then may nakatukod dito. So ibig sabihin, meron siyang mga um, dito meron siya, dito meron siya, and then dito sa ano natin sa taas meron din siyang nakatukod sa kanya. Okay? And then we subdivide yung mga segment niya. So we have 10 feet, 15 feet, and then 10 feet. Okay? So this is our weak axis. Okay. So we have given yung section natin W14/90. Okay? Kunin lang natin yung property niya. So, una, yung AG, ano, kasi gagamitin natin mamaya yung value ng AG. So, looking at your W-shaped table, so hindi ko na i-alisin yung view, ano. So, looking at your W-shaped table, the area is 26.5 inches squared. And then yung value ng ating radius of gyration for X, we have 6.14 inch. For RY, we have 3.7 inch. Okay? So, punta na tayo dun sa first step natin ng analysis. Kasi nasulat na natin lahat ng kailangan natin. Ito pa pala, A992 still tayo. So, kung A992 still tayo, ang value ng kailangan nating value is yung Fy natin. Fu will not be used yet. Hindi magagamit dito, no? Pero lagay na lang din natin. Fy natin is 50 KSI. And then Fe natin is 65 KSI for A992 still. Okay? So, first step is, again, determine yung largest value ng KL over R dun sa column natin. Okay? So, last time, sinolve natin siya ng parang individually, ano? Kung babalikan niyo yung video last time. Pero ngayon, let's try to tabulate para mas organized yung solution natin, ano? So, kung considering yung total number ng KL over R na consider natin, for strong axis, since isang segment lang to, we have one KL over R for x-axis, and then for y-axis, we have 1, 2, and 3. So total, we have 4 KL over R values na i-compare with each other. Okay? So, ngayon, gawin natin, lagyan natin ng dito yung segment na lang. Okay? We have yung value ng K, yung value ng L, and then yung value ng KL over R. Okay? So dito, Lagyan natin yung segment sa x1 na lang kasi isang segment lang. We have y1, y2, then another one, plus 1. We have y3. Okay? So, lagyan natin ito yung segment 1, segment 1, segment 2, segment 3. Okay? And then, let's identify yung mga no, ano natin dito. Okay? So, unahin muna natin yung sa um, may nawawala ano, yung hindi ko nalagay yung sa R. Nadagdagan natin ng column. Okay. Okay, so lagyan natin ng R value. And then, tsaka yung KL over R natin. Okay? So, yung length natin, it should be in inches. Again, yung R natin is in inches. And then, kailangan, yan, magka-cancel out na siya. So, for X1 muna tayo, alamin muna natin yung L tsaka yung R ng lahat ng segment. So, we have 35 feet. So, 35 feet, 35 times 12, para maging inches, that is 420. Okay? For Y1 is this. So, 10. 10 times 12, that is 120. 15 times 12, that is 180. And then this is also 10 times 12, that is 120. Okay? For R, we have yung X natin, syempre ito lang yung 6.14. Then the rest is 3.7 na yung gagamitin. Okay? Now, punta tayo sa K value. Again, K value is dependent on the type of support condition that we have dun sa column natin. So, for first segment, dun sa X natin, we have fix and pin or hinge, ano? So, looking at our table C, dash A, so dito, so pin tsaka hinge. So, case ano yun? That is case B, no? We have pin tsaka fix. Doon, sa ano natin, doon sa value natin. So, kailangan natin is yung recommended, so that is 0.8. Okay? So, this is 0.8. 0.8. And then we have yung sa first segment natin ng Y, that is pin-pin. Pin-pin is 1.0. Dito is pin-pin also, so 1.0. And then yung Y3 natin is pin-fix, that is 0.8. And then, just calculate yung KL over R respectively. Ano? 420 divide 6.14, we have 54.723. We have 120 over 3.7, so 32.43. If 180 divided by 3.7, that is 48.65. And then 1.8, 120, 3.7, that is 25.95. Okay? So, ang governing natin, largest is ito. Okay? So, max KL over R natin is 54.723. It means, ano yung nag-govern? So, ibig sabihin, strong axis govern. Okay? Yun yung ibig sabihin nun. Kung yun yung value na malaki sa atin. Alright? So, yan yung sa first step natin. Malaman yung worst case o yung largest value ng KL over R. Okay? So, okay na tayo sa first step. Second step is to calculate for our FE. And that is just substitution. Pi squared E over KL over R squared. Okay? So we have pi squared. So 29,000 KSI all over KL over R is 54.723 squared. So ang FE natin, so pi squared, so 29,000 divide 54.723 squared. That is 95.578 KSI. Okay? Be consistent tayo dun sa unit, no? Ayan. So, yan yung value ng FE natin. Okay? Next step natin after computing for FE is compute for FCR. Pero i-compare natin muna si KL over R natin from step 1 sa 4.71 square root of E over FY. Okay? So, for step 3, kunin natin si 4.71 square root of E over Fy. So that is 4.71 square root of 29,000 divided by Fy natin is 50. Okay? So 4.71 square root of 29 over 50, that is 113.432 KSI. Okay? Unitless pala, sorry. Kasi this is KL over R, no? Okay? So, again, ang KL over R natin na calculated is 54.723. So, tayo ay less than nung 4.71 square root of 29 over 50. Okay? Therefore, tayo ay inelastic backlink tayo. Okay? So, pag inano natin, ang FCR formula natin will be equals to, inelastic tayo, so less than, so this is yung equation na gagamitin natin. Okay? 0.658 Fy over Fe, Fy. 0.658 Fe over Fy times Fy. Okay? So, substitute natin. So, we have 0.658. Fe natin, kunin natin yung nandito, 95.578. So, 95.578 divided by 50. Naka-fraction yun, ha? And then times 50. Since this is a backlink, critical backlink stress, KSI yung ating unit. Okay? 95.578 divided by 50 times 50, we have 22.464. Tama ba? Wait lang, ha? 95.658. Baliktad pala, no? Sorry. So, it should be 50 over 95 Fy over Fe. Okay, 0.658. So 50 divided by 95.578 times 50. So we have 40.168 KSI. Okay. So we have now our value ng FCR. The next thing now is to calculate for PN agad, ano? So PN na ang kasunod natin. So number 4 is to calculate for the capacity. So PN is equals to FCR times AG. So that is 40.168. KSI is kip per inches squared times yung AG natin based from our cross-section o table, 26.5 inches squared. So substitute lang natin, 26.5 inches squared. Cancel. So 40.168 times 26.5, that is 1,064.452 kip. Okay? Yan yung PN natin. So, kung ang pinapahanap is halimbawa LRFD, so VPN tayo. So, that is 0.9 ng PN. So, this is 0.9 times 1,064.452. KIP. So VPN times 0.9, that is 958 KIPs. So actually may decimal pa, no? 958.01 KIP. Okay? And then for ASD, that is PN over omega. So that is PN over 1.67. So PN over omega is 1064.452 KIP divide 1.67. So PN over omega 1064.452 divide 1.67. That is 637.40 KIP. Okay, so these are your answers for LRFT and for ASD. Ito yung capacity ng given column natin. Okay? So yan yung i-check natin ngayon. Kung halimbawa may given na loading, what will be the value na i-compare natin to determine if the given section, yung W14/90, can withstand any loading that may be subjected to it dun sa lifespan niya. Okay? So yan. So ganyan po i-apply yung steps natin. Question so far? Okay. So very straightforward yung step, no? So ang challenge lang dyan is syempre yung pag-determine yung KL over R natin, ano? So you need to be careful din on using yung value ng RX and RY and also looking at the table. Okay, baka mamali sila ng tingin ng value ng RX and RY na AG. So malaking issue yan, ano, pag namali yun. Okay? So this is our example number 1. Okay? So I think we can do another example just to have further understanding dun sa topic natin. So let's have this example. AW14/74, A992 steel has a length of 20 feet and pin ends. Compute the design compressive strength for LRF, the allowable compressive strength for AST. Okay? So W14/74. So walang explain kung ano yung condition niya on the strong axis and weak axis, ano. If that is the case, always assume na on both axis same lang yung boundary condition natin or yung support condition natin. So for this case, we have pin ends. So ibig sabihin for both strong axis saka weak axis, ito lang yung itsura ng column natin. Okay? And then meron tayong length na 20 feet. Okay? And meron tayong W14/74. Okay? So, AG. So, balik lang kayo sa W shape section natin. That is 21.8 inches squared. RX niya is 6.04 inch. RY niya is 2.48. Correct. 2.48. Okay? And then we have A992 steel. Dito na natin lagay ito. Yan. So, A992. So, ibig sabihin, FY natin is also 50 KSI. Okay? So, pinapanap lang ulit yung design capacity natin. So, same procedure lang as we did earlier. Okay? First condition is to calculate for KL over R. Pero since both axes are the same, pwedeng isang calculation lang tayo. Ibig sabihin, bali dalawa kasi iba yung RX tsaka RY ng isa, no? So, pero isang segment lang tayo, ibig sabihin. Okay? So, meron tayong X1 and Y1. Bigyan lang natin ng ano, baka sabihin kasi ba't sabi itatabulate daw. Okay? So, ito yung K, ito yung L, ito yung R, and then this is our KL over R. Okay? So, ang K natin, since pin connected o pin ended parehas, 1.0. And then parehas 20 feet yung L natin. So 20 times 12. That is 240, ano? 240. And then we have 6.04 and 2.48. Okay? So KL over R 240 divided 6.04. So we have 39.735. And then we have 240 divided 2.48. We have 96.774. Okay? So ito yung nag-govern. Okay? Max KL over R natin is equals to 96.774. Therefore, weak axis governs. Okay? Next, step 2, calculate for FE. That is pi squared E over KL over R squared. So that is pi squared 29,000 KSI divided by 96.774 squared. So that is pi squared 29,000 divided by 96.774 squared. That is 30.562 KSI. Okay? And for number 3, yung 4.71 square root of E over Fy, hindi mo nagbabago yan kung hindi mo magbabago yung value ng Fy. So that is always 113.40, saan yan? 113.432. Okay? 432. Okay? So that is, ang mangyayari, less than pa din tayo or greater than pa din siya dun sa KL over R natin. So, ibig sabihin, inelastic pa din tayo. Inelastic. Okay? O baka biglang malito, no? Sabi pag greater than yung isang equation dapat. Hindi po, ano, nauna po yung 4.71, ano? So, kabaligtaran nito, KL over R is less than nitong 4.71. Okay? So, ngayon, step natin kasunod is yung FCR natin is equals sa same formula natin dito sa previous one. 0.658 Fy over Fe times Fy. So, 0.658 50 divide 30.562. Tama ba yung ginagamit ko kaninang Fe? Okay. Tama naman pala. Dito, pi squared, double check ko lang yung value. Okay. So, times Fy na 50, FCR, 0.658 raised to 50 divide 30.562 times 50. So, we have FCR na 25.211 KSI. Okay? So number 4, so we have Pn is equals to FCR times Ag. So that is 25.211 kip per inches squared times 21.8 inches squared. Cancel to. So Pn natin is 549.592 kip. Okay? So for LRFD, that is just VPN. So times lang natin ng 0.9. VPN is 494.633 kips. Okay? And for ASD, Pn over omega, so 549.592 kip divided by 1.67. 549.592, 1.67. We have 329.10 kip. Okay? So this is our answer. This is the capacity for LRFD, and then this is the capacity for ASD. Okay? Question? Okay, so yan lang po yung sa method 1. Okay? So next meeting, we will be solving the same example pero applying method 2 naman, yung sa table naman. Okay? So to practice how to solve using method 1, I will be posting a problem set sa Neo LMS natin for you to work on and then to be submitted next meeting. Okay? Pero if we don't have any more question, that ends our lecture for today.